So this is a review session for Radio Access Network 5G and Introduction to Open RAN course. Okay, so let's start now. Okay, so it's a faculty development program. So we start with the question number 1. Okay, so we have 40 slides now. So these are time varying voltages or currents that are continuously changing, such as the sine or cosine waves. So which one? Ano yung mga time varying voltages and currents na continuously changing? Is it transmitter, the digital signals, or analog signals, or the receiver? Tingnan natin. Yan. So analog signal siya. No? So let's see kung sino yung ating top 1 for this question. So si Ata, si HMSU, and si Jokes. Okay, si Abs and si ET. Okay. So analog, no? Analog signal. So that is the main reason. Kapag binalikan natin, when we go back sa introduction ng electronic communications, so it's just a transmitting your message or information or intelligence from one point to another. So the information source could be an intelligence, okay? Or in analog form, meaning it's a human voice, it's a continuous data and or music. Or it could be a digital form. It's a binary coded numbers or alphanumeric codes coming from a computer or an IoT device. So, dalawa yung information source na tinatransmit natin. So, an analog or a digital. And then it will go to the transmitter. Kakaroon tayo ng modulation. Okay. And then sa pinaka-system natin, we have the transmission medium or communication channel. So, yung communication channel natin could be a physical facility like metal, yung copper wire or fiber optic. Or we can use a free space like the Earth's atmosphere, yung mga microwave or satellite communication. And then after that, that information will be received by the receiver through an antenna, okay? And then it will be demodulated or convert into another form. Could be into analog form again, a voice or music, or in digital form, like a binary coded or a text message, no? So, ganun yun. Ako, for example, meron akong tumawag ako, I want to transmit an analog form like a human voice. Okay, and then it will be demodulated, converted into digital, and then transmitted to the transmission medium, could be copper or wireless or free space, and then it will be received to the other end, and then it will be converted back to analog form. So, naririnig ko na yung kausap ko. So this is the introduction to electronic communication. So particularly transmitting and receiving information using an electronic means. Okay. So we go to question number 2. So Marites is talking to her friend using a mobile station. What technology is she using? Ano daw ginagamit ni Marites, no? So gumagamit siya ng mobile station. So this question is to test kung ano yung knowledge natin about the names or the jargon sa ginagamit natin sa telecom industry. So if we're using a mobile station, definitely the technology that is being used is GSM or the Global System for Mobile Communication. Why is it like that, no? We'll see in this next slide. Okay. So if we go back sa wireless telecommunication system, so it's an easy as 1, 2, 3, right? So you have the user terminals connected to the radio access network and connected to the core network. And then if we look at the user terminals, iba-iba yung tawag natin dyan. It depends on the type of technology that we are using it. So mobile station if we are using for 2G or GSM. And user equipment naman if it's 3G, 4G, or 5G. And then it will be connected to radio access network, which is meron ding iba't ibang tawag. For 2G, that is the base station or base transceiver station. For 3G, we call it the node B. For the 4G, we call it the E node B or the evolved node B. And for the 5G, we call it the next generation node B. And then it will be connected to the core network using microwave, fiber optic cable, or via satellite. Okay, so that's the summary of the wireless telecommunication system. Easy as 1, 2, and 3, and just connecting the dot, no, from user terminals to the radio access network going to the core network. Now we'll proceed to question number 3. Double points. Which agency is in control of allocating frequencies and services within the overall frequency spectrum? NTP na to. Nice, no? Everybody got it correct. Okay, so far, ang nauuna pa rin si ATA, followed by RS, CHOPS, GC, and ET. Yeah, so radio access network is using what we so call the spectrum or frequency. So pag sinabi nating spectrum, this is a fundamental asset that provides wireless connectivity. Pag wala tayong spectrum, it's very difficult for telecom operator to perform. Or even yung mga private entity na gusto mag-deliver even a Wi-Fi. If you will see, yung spectrum is divided into 2. We have non-ionizing radiation and the ionizing radiation. So to simplify this, ito yung mga radiation that is not impacting any health, no? Effect sa ating katawan. And then ionizing radiation, ito yung may mga adverse effects sa atin kapag na-overly exposed tayo. So sa non-ionizing radiation, kasama dito yung visible light, no? Yung liwanag ng araw or ilaw, and then going to infrared, microwave, yung mga ginagamit ng microwave oven, Bluetooth, Wi-Fi, microwave transmissions, cellular phones, and then radio waves katulad ng FM, AM, and television. And then even yung mga walkie-talkie. So dito lahat sila gumagana. Okay. On the other part, yung ionizing radiation, ito yung mga part ng spectrum that has a lot of energy. So kasama dito yung ultraviolet rays, no? Nung mga bata tayo, alam natin kapag natamaan ka ng ultraviolet, medyo delikado. X-rays also included, and also gamma rays. Yan. And then mga cosmic ray. Yan. So, spectrum is an invisible electromagnetic wave generated by a radio transmitting device. Katulad ng mga cell sites na ginagamit natin. And then it is measured in hertz. Pinangalan kay Heinrich Rudolf Hertz. Siya yung nag-demonstrate ng presence ng electromagnetic energy. And then ang mga operator, for them to operate in this spectrum, they need to pay an annual fee na ang pangalan is spectrum users fee. And ang license are normally 10 to 20 years in duration. So sa Pilipinas, ito ay minemaintain or minamanage or nire-regulate ng isang agency which is we call the National Telecommunications Commission. So anything na gumagamit ng frequency or wireless spectrum, so you need to have a type approved by NTC. Okay? Okay, question number 7. So LTE can work in FDD mode. So what does FDD mean? Ano ibig sabihin kapag sinabi natin FDD? So FDD means frequency division duplex. So balikan natin anong ibig sabihin ng FDD. So sa ating modes of operation, meaning modes of communication system, meron tayong dalawang klase. So meron tayong FDD at meron tayong TDD. FDD means frequency division duplex, meaning yung communication between the mobile station and the base transceiver station are separated through their frequency. Meaning tayong uplink, so from mobile to cell site, uplink. And then cell site going to mobile, we call it the downlink. If we are using different set of frequencies for those channel, we call it FDD. On the other hand, if we are using only one frequency and then separated by time, we call it the time division duplex. So there are systems in cellular technology that uses FDD and also meron gumagamit ng TDD. For example, si GSM, it is using FDD. Si UMTS or si 3G, it's either FDD or TDD. Kasama si LTE at si 5G. Okay, so depende sa frequency ginagamit niya. Okay, so that is the mode of operation. Question number 3. Pinag-usapan natin yung LTE kanina. So, LTE means what? Anong ibig sabihin ng LTE? Is it long-time evolution, low throughput evolution, long-term evolution, or the last-term evolution? Nagkamali dito. Long-term evolution ng LTE. Okay? Tingnan natin kung nabago to. Wala naman. Okay, so yung cellular technology natin or the radio access network evolved, no? Through time. So from 1980 to 2020, we have witnessed yung evolution ng technology. So actually, it's almost every 10 years. So nagsimula sa 1G, okay, the foundation of the mobile technology. And then nung 1990, dito nagsimula yung 2G or the digital communication system. Pinaka naging sikat na 2G is the GSM, the global system for mobile communications. And then furthermore, naging foundation of the mobile broadband. No? This is the first time that people can actually connect to the internet and browse the internet, watch YouTube or download the data from the internet using their mobile phone. Kaya tinawag na mobile broadband. So it includes yung 3G or the Universal Mobile Telecommunication System. And then later on, nagkaroon ng madaming demand sa use ng internet. People starts to upload, download, watch Netflix, stream sa mga YouTube. Okay? So kinakailangan natin ng mas mabilis na technology. That's why LTE came into the way. No? Yan. So dito nagsimula yung 100 Mbps sa downlink and 75 Mbps sa uplink. And then now we are in the era of 5G. So hindi lang tayo nag-download, upload or nanonood ng mga streaming sa streaming platforms. We are also looking at different use cases. We want to have a technology that is using low latency communications, and we also connect a lot of devices or a massive number of IoT devices to the network. Okay, that's why 5G is developed. No, so this is the future of mobile communications. So ito yung evolution ng mobile communications natin from 1G, 2G, 3G, 4G, and 5G. 11. So it processes baseband signals in the equipment room and it is connected to the RRU by optical fiber. Anong tawag natin dito? Okay, anong tawag natin dyan? Yan, tawag natin is baseband unit. So balikan natin, no, yung naging top 1 na si RS. Naunahan niya na si ATA. So balikan natin yung component ng isang cell site or radio access network. Okay, so meron tayong tower structure. So dito natin kinakabit yung ating mga panel antennas. Okay, so yung panel antennas, siya yung nagda-direct, no, or nagpo-propagate ng direction ng electromagnetic energy natin. It's like a flashlight. Meron tayong ilaw pero the reflector is not the ilaw, right? So the ilaw comes from the remote radio unit. Okay, but the reflector itself, we call it the antenna. Ayan, so the antenna is connected to the remote radio unit that generates the electromagnetic energy. And then the remote radio unit is now connected sa baseband unit or the BBU. So this is something like the central processing unit ng ating cell site. Yung mga CPU natin sa computer. And then the baseband unit is located inside the outer cabinet for power supply, transmission, ventilation, okay, and backup battery. Okay? And then itong BBU na to, nakakonekta na yan sa core network. Kaya dito, meron tayong microwave antenna going to the core network. Okay? So these are the components, no, ng isang radio access network. Okay. So it's a model that shows how computer systems use the 7 layers to talk to each other over a network. Ang tawag natin sa model na yan. Is it a TCP/IP model? Is it the OSI model? Sagot na pala na. May propagation model or the UDP model. ang tawag natin dito. And so it's an OSI model, no? Open Systems Interconnected. May sagot na dun sa may bonus. Okay, so RS still on the top one, followed by ATA. Yan. So, ang radio access network, if we will map no yung type yung protocol na nangyayari sa kanya when it handling the communication system from one layer to another, we can use the what we so called the OSI model. OSI means Open Systems Interconnection model. So ito yung concept that describes and standardize how a computer or telecommunication system communicates. Okay? So meron siyang step-by-step process. So as we have mentioned, so if you want to memorize yung different layers from physical, data, network, transport, session, presentation, and application layer, you can just use the mnemonics. All people seem to need data processing. Yan. So that's the common way of ano. But if we use the IORA's version, and if you're here in the Philippines, right? Ang pulis sa tulay na dupa. Yan. Ang pulis sa tulay ang pulis sa tulay na dapa. Yan. Okay, yan yung ano. Medyo lang ng konti. Okay. All right. So that is the RAN and OSI model. And then if you will map the layer of the radio access network onto the OSI model, you can see that you will see that these three layers, the network data layer, the data link layer, and the physical layer are embedded in the radio unit and the baseband unit. Okay, yung other layers are in the other part of the network. Could be on the transmission and also in the core network. Okay. A logical node hosting the RRC, SDAP, and PDC protocol. Ano yung node na yan? So it's a hardware or a virtual function na nag-hold ng mga functionalities of protocol na yan. Yan. Si centralized unit. Okay? Yes. So si centralized unit, ito yun. Okay, so kung pag-usapan natin yung mga protocol, kung i-map natin, so we have these three layers, the physical layer, okay, the radio link control layer, and the PDCP, no, and RRC protocol layers, no. Okay. So nandito yan sa centralized unit. The functions are located in the distributed unit, and yung other functions naman, yung mga low physical and the RF part is in the radio unit. Okay. 17. So in 5G, what is the meaning of NR? Ano yung sabihin ng NR? So, I think we are transitioning from the radio access network going to the 5G mobile network systems. New isa lang nakatama or napindot lang ng iba. New radio. New radio ang ibig sabihin ng 5G, NR. Okay? Hindi new range or no radio or next radio. Okay? So 5G is the 5th generation ng mobile communication, pang-5. Okay? So gumagamit siya ng bagong radio access network or radio access called NR or new radio. And then kapag pinag-uusapan natin yung NR, wala tayong ibang technology pinag-uusapan, kundi 5G lang. If somebody tells you na ang 5G ay 4G, mali yan, ano? Or 5G is LTE, or LTE, or 5G is GSM, mali yan. So, 5G is, or NR is a 5G technology. Okay? So, meron tayong core network na ang tawag natin is 5G core network. Okay? Ito yung ating holy grail. And then, pinaka-importante dito is meron tayong 3 distinctive classes of use cases. Enhanced mobile broadband, meaning high data rates and high traffic volume. Massive machine type communications or MMTC. Ito yung massive IoT. Sabi nga ng Ericsson, everything that can be connected will be connected sa internet. No? So, lahat ng pwede mo maisip na i-connect sa internet, i-connect mo na. No? So, that's what we call the massive machine type communications. And in terms of latency and reliability, we have this use case. Ang pangalan is the ultra-reliable and low latency communications. When we say ultra-reliable, the downtime could be as 99.9999%. Okay? And in terms of latency, up to 1 millisecond. Ganun kabilis, no? Yung ating latency sa 5G. Okay, so this is the 5G. Okay, next question. So in 5G NAN standalone or NSA, which core is being used? Yan, which core is being used kapag ka NAN standalone? So, yung bold packet core, the GOD, 5G core, or a mobile switching center. Evolved packet core, NSA. Ano ba yung NSA, sir? Okay. Ang NSA is ito, non-standalone. Ibig sabihin, this is the fastest way to implement 5G. That's why here in the Philippines, ang lahat ng 5G system natin so far is on the NSA mode. Ibig sabihin nun, meron tayong LTE system, kinabit lang natin si 5G sa LTE system natin. Ibig sabihin, nakigamit tayo ng core network ni LTE at nakikabit tayo as secondary node sa LTE node B natin. Okay? We call it the non-standalone mode. However, yung ating holy grail, yung pinakagusto natin talagang destination sa 5G is the standalone mode. When we say standalone mode, merong sariling core network si 5G. Hindi siya nakikibahay, hindi siya nakiki Airbnb kay LTE, no? So meron siya sariling core network. Ang kagandahan diyan, kapag meron tayong sariling core network, we can maximize all the use cases. So far sa non-standalone mode, what we can only utilize is the EMBB, the enhanced mobile broadband. Yung dalawa, yung massive machine type communication at ultra reliable and low latency, hindi natin siya ma-fully utilize dahil wala siya nitong capability ng 5G core network. Okay? So ito yung ating dalawang network architecture, non-standalone mode at stand-alone mode sa 5G. So in wireless telecommunications, what is the meaning of MIMO? Yan. So is it multiple inside, multiple outside? Multiple ingress, multiple output? Multiple input, multiple output? Or many input, many output? Okay. So multiple input, multiple output. Yan. So ang MIMO, okay. Oh, yun na top 1 ulit si Ata, no? Okay. So ang MIMO is an antenna technology, no? Antenna technology. So ang ibig sabihin nito is dumarami yung transmitter natin or streams natin and compared sa mga traditional implementation. Imagine yung frequency natin is kalsada and then we will use this kalsada to transmit or for example, meron tayong mga delivery ng gulay, no? For example, meron tayong 10 tonelada ng gulay. And then we can just put 1 tonelada or 1 tonelada in one sasakyan and then go use that road. That is what we call the SISO. 1 tonelada, 1 sasakyan and then 1 road. But if we will use 4 roads, 4 sasakyan and then 1 tonelada each, that is 4 tonelada in one go. So it's physically it's literally saying 4 times, no, yung ating throughput if we are using MIMO antenna compared with a single input, single output, multiple input, single output, or single output, multiple single input and multiple output. So that is MIMO, no? Multiple input, multiple output is all about. So na-maximize natin. Kaya when we are implementing 5G, may nagtatanong sa akin mga estudyante, Sir, mandatory ba ang MIMO? Mandatory po ba ang MIMO sa 5G? Hindi naman, pero impractical kung hindi ka magma-MIMO. Ibig sabihin, sayang yung technology. Because there is a capability And then kapag ka nag 5G ka, which is capable of 1 gigabit per second, and then you can only use SISO, gagamitan mo ng maliit na technology, bababayan ng mga 100 Mbps lang. Ang question is, bakit kapag nag 5G, nag-LTE ka na lang dapat? So meaning, kung nag-MIMO ka, kung naka 5G ka, dapat mag-MIMO ka na. Yun yung pinaka best practice and industry standard. No? Mag-MIMO ka na kapag ka naka 5G because that is the um, way forward. Okay. Ano ba mga typical example nun? For example, naka-iPhone naka-iPhone 15 ka. iPhone 15 ka, no? Na hindi maganda example yan. Hindi maganda example. Pero yun na nga na, yun na nga na, yung mag-ano doon. Ayan. So kung kumbaga meron kang Ferrari, padaanin mo sa magandang kalsada. Yan. Okay? Paggawan mo ng MIMO. Yan. Kapag ka naka-Ferrari ka, tapos lubak-lubak yung kalsada, parang pangit. Nakasaiso ka lang. Yung maximize yung performance ng sasakyan. Okay? Okay, multi-select. So you need to select two frequency ranges ng 5G. So ano yung dalawang frequency ranges ng 5G? So if we implement 5G, meron siyang maraming frequency. Ano yung mga dalawang frequency ranges? Is it FR3, FR1, FR2, or FR0? Ano kaya, no? And FR1 and FR2. Ibig sabihin ng FR1 ay frequency range 1 at frequency range 2. Yan. Frequency range 1 at frequency range 2. Ibig sabihin ng frequency range is the whole set of band. No? Frequency range 1, ito yung mga less than 6 gigahertz. Nandito yan. And then frequency range 2 starts from 24 gigahertz hanggang 70 gigahertz. No? Yan. So ito yung tinatawag din nating millimeter waves, yung FR2. Okay? Ito naman yung mga sub 6 gigahertz na frequency. Okay, so pwede natin ma-implement ang 5G using these frequencies. Depende kung naka-assign sa'yo ni NTC. So sa 5G, anong mode of transmission? Can we implement FDD or TDD sa 5G? So ang question dito, 5G mode of transmission can either be FDD or TDD. Pwede bang parehas or FDD lang or TDD lang? It's true, no? Yeah. Kasi it has a lot of frequency range, right? So depende sa frequency range. So meron kang FDD na frequency at meron kang TDD na frequency. Kaya pwede natin gamitin FDD at TDD si 5G. And then in this example, you will see there is a supplemental downlink and supplemental uplink. It's just another downlink channel kung kulang ka sa capacity and another uplink channel kung kulang ka naman sa uplink frequency. Kaya ito lang yung dalawang yan. Pero definitely itong dalawang yan, FDD and TDD. True or false? Ang 5G network ba can be deployed as a private or non-public network? Or sa public lang to? Pwede ba natin to i-deploy as a private network? Yan. True, no? Pwede. Actually, meron tayong 4 na options for deploying private network. So, meron tayong standalone. So, in the standalone, yung ating enterprise ay meron siyang sariling core network at meron siyang sariling frequency. Hosted by MNO, so kumukuha lang siya kay MNO, naglalagay si MNO ng cell site dun sa loob nung ano niya, nung company or nung kanyang manufacturing plant. So, that is the hosted by MNO. RAN sharing is yung signal galing kay MNO pero yung core network or yung cloud network niya, yung edge server niya, meron siyang sarili. Hindi niya binibigay kay MNO yun. Ang tawag din sa RAN sharing. And then MNO slice is binibigyan lang tayo ng SIM card and then sa SIM card nakalagay yung parang APN number. So sa APN number, magkakaroon ka ng sarili mong slice sa network. Okay. Ibig sabihin, meron kang parang virtual private network na binibigay. So definitely, ang 5G is applicable for a private network. Okay? So what is network slicing in 5G RANs? Ano ba yung 5G slicing? Is it the ability to divide the network into separate virtual networks? Or the ability to switch between different networks on the fly? Or the use of small cells to improve network coverage and capacity? Or the use of single network to provide multiple services? Yan. So, ito yung sabi natin, ano? So, isang part ng application ng 5G which we can use is yung paggamit ng network slicing. And then network slicing is a service-based logical network. So, meron tong kanya-kanyang end-to-end QoS, no, quality of service for optimal resource sharing. So, fundamentally, we have three network slices. Of course, yung tatlong use cases. Mobile broadband, URLLC, and MMTC. Okay? And then each network slice has a segment of RAN, segment of core network, transport network, and meron silang sariling server and suitable lifecycle management. Ano yung sabihin nun, sir? Ganito yan, ano? For example, network slice. Pag sinabi niya segment of the RAN, pagka ang mga devices natin ay IoT devices, for example, mga CCTV cameras along EDSA, i-connect natin. Hindi yan sasama sa lahat ng mga mobile broadband, sa mga telepono, sa core network. Ang mangyayari dyan, sa radio access network pa lang, hihiwalay na natin sila. Paano hihiwalay yon, sir? Paano mahihiwalay yon? Mahihiwalay sila by the means of separating them into different frequency. Okay, for example, yung mga IoT devices, ilalagay natin sa 900 MHz. Yung mga typical commuter na sa 1800 MHz. So, dun pa lang, meron na kayong slice. Okay? So, that's a typical example ng network slicing na ginawa mo sa radio access network. And then, pagdating sa transport network, meron kang different priority. Pagdating mo sa core network, meron kang different server na pupuntahan. Hindi kayo magkakahalo sa isang server. Okay? So, that is the fundamentals ng network slicing. Okay, papunta na tayo sa Open RAN. So, this is a disaggregated RAN functionality. So, using open interfaces, specifications between elements. Ano daw tawag natin dyan? Open RAN. Yan. So, papunta na tayo sa Open RAN. Okay. So, ang radio access network, nag-evolve din yan, no? Aside from the technology. Ito naman is the evolution of radio access network in terms of architecture. Okay, kanina nag-evolve siya in terms of technology from 1G to 5G. Ngayon naman in terms of implementing, no, yung architecture na yan. So meron tayong four major architecture evolutions. Yung traditional network, or we call it also the distributed network, in which ito ang ginagamit natin sa ngayon sa Pilipinas at sa ibang bansa. Yung baseband unit at yung remote radio unit nandun sa may cell site. So ang kagandahan niyan, mas tipid yan sa transmission. Ang kapangitan niyan, kapag hindi mo nagagamit yung equipment, nandun na yun. May sunk cost na yun. Ibig sabihin, kung meron kang Ferrari doon, tapos hindi mo naman ginagamit, sayang, no? Nandun lang siya. Nakatiwangwang. Ayun, yun yung salita na, nakatiwangwang yung equipment doon. Walang gano'ng gumagamit. Okay? So, that is the traditional network. And then, pumunta tayo sa centralized network, which is yung baseband unit, ginawa nating centralized para mas mabilis yung operations natin. Ano yung sabihin nun? Kasi dati, kunyari merong baseband unit na nasira, nasa Batanes, pupunta pa ako ng Batanes. Ano? Punta pa ako ng Batanes, no? Kung malayo yan, talagang minsan yung babangkain mo yan, no? Minsan, lalakarin mo yan. Pero kung naka-baseband pool yan, sabihin, nandun na yung nasa sa central location yan, not necessarily kailangan ko pumunta sa bawat location ng cell site. Pumunta na lang ako sa central office, doon ako mag-upgrade. Yun yung motivation sa centralized network. And then after that is the virtualized network. itong mga functionality na to, ginawa nating virtualize para mga applications. Kapag ayoko nung app, didelete ko siya. Pagka kailangan ko nung app, i-install ko siya. Mag-edit ako ng picture, kailangan ko ng editing software, install ko siya. Pag ayoko na, delete. Ganon din dito sa virtualized network. Pagka kulang yung ating resources, hindi ko kailangan mag-plug in ng hardware. Software lang, configuration. Kailangan, doon ako pwede mag-upgrade. So, mas mabilis. For example, nasa EDSA tayo, mula alas 8 ng umaga, alas 6 ng umaga hanggang alas 10 ng tanghali, maraming sasakyan sa EDSA. So, kinakailangan ko ng maraming resources. And then from 10 to 4 p.m., konti lang yung dumadaan na, so tanggalin ko na resources, lilipat ko sa iba. So, ganun ka flexible yung virtualized network. Okay? So, nakukonfigure mo siya through software. However, nung ginagawa yan, still proprietary. Ibig sabihin ng proprietary, yung mga equipment, all, no, from the baseband unit hanggang sa remote radio unit, bibilin mo pa rin yan sa isang vendor. Hindi pa rin yan open. Dito na inintroduce si Open RAN. Yan. So si Open RAN could be a virtualized RAN also. Basta ang concept lang natin, lahat ng mga hardware are using a general purpose processor and then software defined katulad ng virtualized network, pero open yung interfaces. Yan. Open yung software and then open din yung hardware. So we can also mix and match yung mga equipment at mga software natin. So ito yung promise ng Open RAN. No? Okay. Multi-select. So ano yung dalawang initiatives, no, na nagsusupport sa Open RAN? Yan. So meron tayong bagong movement of deploying the radio access network. But of course, kung meron bago, we need to have a standard. Okay? We need to have somebody that will regulate yung mga specifications, okay, at gagawa ng mga specifications. Sila si TIP, si Telecom Info Project, at si ORAN Alliance. Yan yung dalawa. Okay? So sila yung nag-support sa Open RAN. So si TIP, ang ginagawa niya is more concerned sa deployment and execution. So gumagawa siya ng mga plug fest, live deployments in the field. So ibig sabihin ng plug fest is may dala ako equipment, pag-connectin natin yung plug fest. Parang stag party ng mga aso, no? Dala mo yung golden retriever mo, dala niya yung golden retriever niya. Tingnan mo ako magpapasto. Yan. Yan yung plug fest, no? So, titingnan natin kung nag-i-interoperate. Yan. So, yun yung ginagawa ng TIP. Okay? So, si ORAN Alliance naman, siya yung nagke-create ng mga standard, ng mga specifications. Yan. So, ganun yung ginagawa niya. No? And most of the time, 4G and 5G centric sila. But si TIP is sinasama niya yung 2G, 3G, 4G, and 5G. Okay? Pero wala silang overlapping ng activities or responsibilities. Okay? So, double points. What is the meaning of Open RAN? Dali lang ito eh. Meaning of Open RAN. Is it Open Radio Access Network? Open Random Access Network? Overall Radio Access Network? Or Open Radio Access Network? Dali lang. Yan. Open. Oy, buti na lang. Wala nagkamali. Very good. Okay. Ayan. So, Open RAN means Open Radio Access Network. So, actually, it's not a new technology, no? It's a new movement or new approach in building the RAN. Okay? So, gumagamit siya ng disaggregated, magkahiwala yung hardware at software, but interoperable. Sabihin, from one vendor to another vendor, you plug it in, so it will work. And it will use the general purpose processors, yung mga typical na servers na nabibili natin sa Dell, okay, or sa NEC. You can use that hardware. And then, get a software company that will help you virtualize the functionality ng mga baseband unit and then mag-develop rin ng mga X-app. Okay, so that's what we call the software-defined technologies. And of course, kinakailangan yung interfaces niyan are open para ito mag-usap, no? Pati ito, kahit na magkakaiba tayo ng equipment. So yun ang kagandahan sa open RAN. You can mix and match and then you can select which vendor is fit for the requirement of the operator. Hindi na sila nakalock, no? Hindi na sila katulad ng nakalock kay Huawei, puro Ericsson, puro Nokia. So this time, kung natatagalan ka sa development ng isang vendor, you can select another vendor. Then put it in your system. So that's the beauty of Open RAN. Okay, multi-select. So, si Open RAN is mag-focus tayo kay Oran Alliance. So, meron tayong merger ng dalawang organizations na nagbuo kay Oran Alliance. Sino yung dalawang mergers na yan? Nagsama para buuin si Oran Alliance. Si X-RAN Forum at si C-RAN Alliance. Yan. Okay, number 2 na si Jobs. Si Ata is number 1 pa rin. Yan. So, si Oran Alliance is dalawang grupo dati yan. So, una si C-RAN Forum, founded in 2009 by China Mobile, isang telecom operator sa China yan. And then si X-RAN naman is founded in June 2016 ng mga American and European sa AT&T and si Deutsche Telecom. Okay? So, nagsama sila, ginawa yung Oran Alliance. So, ang founding operators niyan ay sila AT&T, si China Mobile, si Deutsche Telekom, NTT Docomo, at si Orange. Yan. Pagka nasa France ka raw, Orange na. Pero sa atin, Orange yan eh. No? Sa Pilipinas, kahil yan eh. Yan. Pero sa ano, Orange daw. So, na-form yan noong 2018. Okay, so ang goal niyan is to promote an open and intelligent RAN. So, okay, so second organization sila. So, ang unang organization si TIP, si Telecom Info Project. Okay? So, yun yung dalawang nag-merge no, na organization. Si C-RAN Forum at si X-RAN Alliance. Okay? Now, we're going to the last question. O yan, kailan na-form si Oran Alliance? When did the Oran Alliance was formed? 2018, 2017, 2016, or noong 2020? Ayan, 2018. Okay? Nandun na sa kabilang slide eh, 2018. Ayan. So, ang Oran Alliance is a group of telecom companies that aim to improve yung performance and openness ng network. Ang kagandahan dyan sa Oran Alliance, meron silang goal to have a more intelligent network. Kaya papasok tayo dun sa RAN Intelligent Controller, which is powered by artificial intelligence and machine learning. Okay? So, kaya yung artificial intelligence, machine learning, kasama yun sa Open RAN courses natin. However, yung mga napapanood natin sa mga webinars natin ngayon, nakafocus tayo dun sa ChatGPT, kay Bard, no? Pero there's a different set of artificial intelligence that are particularly focusing sa telecommunications. So, ang ginagawa ng artificial intelligence na to is that they are managing yung mga resources and then yung performance ng system. Instead na engineer ang gumagawa nun, na napupuyat, okay, naiinis minsan. Okay. Si artificial intelligence, wala siyang reklamo. Ayan. So, and handling this complicated and complex task can be handled by artificial intelligence, no? Pag-analyze ng trend, pag-analyze ng resources, kung saan niya ilalagay yung resources, no? So, kayang-kayang gawin ng artificial intelligence, no? Lalo na sa era ng big data. Sa dami ng data, minsan minsan susuko yan. Lalo na kung wala kang server o wala kang database, Excel lang gamit mo, maghahang yung Excel. Pati yung laptop mo maghahang. So, kaya kinakailangan natin yung artificial intelligence to be embedded sa mga radio access network natin. Okay? Yep, so that is our FDP RAN 5G and Open RAN review. No? So, tingnan natin sino yung top 3. Si RS, si Job sa top 2, at top 1 I see. Kanya naman. Tawa na natin. Number 4 and